Hi, this lecture is based on the transportation network problem, and it's all about the tropic sun, which has farms, I would say, or places where they are producing fresh fruits, and they have three sources, which are Mount Dora, Eustis, and Claremont. And Mount Dora has 275,000 bushels, Eustis has 400,000, and Claremont has 300,000. And all these products have to be shipped to the processing centers, which are Ocala, Orlando, and Leesburg. And each one of these has the capacity to handle. For instance, Ocala has 200, Orlando has 600,000, and Leesburg has 225,000. And so also we are given the distance in miles from the grooves to the processing plant. So this one here should be Mount Dora, Eustis and Claremont, and Ocala, Orlando, Leesburg. So we can see the miles from the groove to the plant. So we are supposed to minimize the distance of the bushels that will be shipped to the processing center. So we can use Excel to create the model. Instead of using the tropic sun, I'm going to use Enos company. And if you can remember, the first thing that we did was to have these miles. And so I'm going to write here, okay, distance from rows, or I'll say distance from the source or the sources to destinations. And so here we have Mount Dora. So Mount Dora, and so let's say the sources, Mount Dora, Eustis, and also we have Claremont. These are the sources. And then we have Ocala, and then Orlando, and Leesburg. So from Mount Dora to Ocala, we have 21 miles. And from Eustis to Ocala, we have 35 miles. And from Claremont to Ocala, we have 55 miles. And so from Mount Dora to Orlando, we have 50 miles. From Eustis to Orlando, we have 30 miles. And from Claremont to Orlando, we have 20 miles. And finally, we have Mount Dora to Leesburg, we have 40 miles. From Eustis to Leesburg, we have 22 miles. And from Claremont to Leesburg, we have 25 miles. So let me just copy this, and I'm going to paste them here. But now we are going to look at not the miles, but we're going to look at the quantity shipped. So let me highlight that. So we're going to see how much should be shipped from Mount Dora to Ocala, to Orlando, to Leesburg, and the same with Eustis and Claremont. However, these are the decisions which should be made, and therefore they will always change. So I'm going to put just zeros for now, knowing that this will eventually change depending on the decisions. So let me highlight this and give it some colors. And so I will define the color. That color shows are the changing variable cells. So they'll be changing. So you can see that Ocala is receiving some fruits from Mount Dora, from Eustis and Claremont. And so we can find the total number or the total bushels which they receive from all these three centers. And so right there, the amount received, and that will be the sum of all this. So I will put equal sign and type sum. So I'll select the sum, and then I'll select these three, and so we can get the sum of the quantity of fruits which were received from all these three sources to Ocala. So let's say Ocala received 24. You can see they will add here. If they get 24 from Mount Dora, let's say they got 3 from Eustis, you can see it's adding. And so if we have 10, you can see that it is still adding. And so if these are the bushels coming from Mount Dora, Eustis, and Claremont, then you can see the total. So we can copy this. If you can put your mouse there and you see it gives you the plus sign, so you can drag two other plants in Orlando and Leesburg, and you can see the total for Orlando. If you look here, we have the sum, and also if you click there, you can see the sum. So I'm going to put this to 0 for now. Just put zeros for now. So if this is the amount which was received, and let me put this. So that means Ocala has the limit, has the capacity of how much they can receive. And if you can remember, here we have the amount that can go to Ocala is 200,000, and to Orlando 600,000, and to Leesburg is 225. So let me put the capacities for all these three plants. So we have 200,000, and then we have 600,000, and then we have 225,000. So that means Ocala cannot receive more than 200,000. That's its capacity. It is the limit. And also, Orlando has the limit of 600,000. Leesburg has 225,000 limit. So they can receive less or equal to this, to their capacity. So we can write here limits, and so the limits here should be less or equal, and that will be for all of them. And so we can drag this all the way, and so that's all with the plants and their capacity, or how much they can receive. But now we can look also on how much we can ship from Mount Dora to Ocala to Orlando and to Leesburg. So here is shipped, the amount which is shipped. So to know the quantity shipped from Mount Dora, we're going to add what goes to Ocala, to Orlando, and Leesburg. So we're going to put equal sign, and we can sum. And in this case, we will sum everything that comes from Mount Dora. And so we can close the bracket and enter. For now, you can see we haven't shipped anything, and therefore the total shipped is just 0. So we can copy this by dragging it down. Remember, you have to make this a plus sign. Hold that corner, drop down, and so you can see we have the summation for all of them. And so then we should see how much do we have to ship from the sources. And so we can see the available quantities. And so we saw that Mount Dora has 275, Eustis has 400,000, and Claremont has 300,000. So let me put them 275,000 and then 400,000 and then 300,000. So these are the limits, meaning that Mount Dora has this amount, and Eustis has this amount, and also Claremont has this amount, and they have to ship them to Orlando, Ocala, Orlando, and Leesburg. So remember, these are fruits, and therefore they have to ship everything. And so let's go with our limits. And so what they have to ship is all these quantities, otherwise they will perish. So I'll put equal sign and enter, and then I will copy this way down, meaning that we are not using equal or less, but they should be equal to, and it is exactly the same amount that we have. So finally, we want to minimize the total distance. So minimize total distance, and we can minimize it here. And all we need to do is to minimize the quantity shipped by looking at the miles, minimizing the distance by transporting the quantities to the right place, to the closest as much as possible. So we can put equal sign and type some product. So you can select some product, and so we will select all this and then put comma sign and then select the miles, all of them, and then you can close the bracket and enter. So you can see that the total distance we have utilized up to this moment is 0 because we haven't shipped anything yet. So this should be our objective cell. So now let me use another color. And let me use a different color. Let's go with that. And so let me define the color. So that one will be the set objective cell, this color. So now we are done developing our model, and so the next thing we need to do is just to use Solver to solve this problem. So I'm going to click on the data to see if I have Solver. Yes, I have it here. If you don't have it, then you need to add ins and get it. So let me use the Solver, and the set objective cell is the one with this color, which is the 0, or this cell here, G17. And then we are not maximizing, but we are minimizing the distance. And so we can do so by changing some variables. So here we have changing variable cells, and in this case the changing variable cells are all this. So they are changing variables, as I said, because these are the decisions variables. We can decide how much we're going to ship to all these centers. But now we're going to add constraints, and so the first constraint can be either this one or the other one. So let's go with this one. where we're going to look at the quantity shipped. So highlight everything and change this sign here to equal, and it should be equal to the corresponding values, meaning that the quantity to be shipped should not exceed or to be less than this quantity. They should be exactly the same quantities that will be shipped. And so let me add another constraint. So click add. So we have this limit here, and we're going to define it. And so the cell reference will be the quantity received. And this quantity received should be less or equal to the capacity. And that's what we have here. So I'm going to click here and click on the capacities. Capacities for the 3 centers. And so we are defining the constraints that we cannot receive more than these capacities, but we can receive the same or less. But we have to add one more constraint, which is non-negative constraint or non-negativity condition, where we cannot make this negative. We cannot ship anything negative. Either we should ship or we should not. So it can be 0 or it can be something, not minus. So we're gonna change this to greater or equal, and that should be greater or equal to 0. I'm going to write there 0. And so we have no any other constraint, and so we can click OK. Here, make unconstrained variables non-negative, we did, and so please click here, and we are going to change from GRG non-linear to simplex linear programming. We may go with options, but let's see first the quantities that we have, if they can be of a fraction or not. So we can solve. If you click solve, so for me it says solver found a solution. All constraints and optimality conditions are satisfied. So if you followed everything that I did, you will get this response. If you made some mistakes, you won't get a solution. So you have to go back and check where you made mistakes. So let me pull this on the side and see what we got. So you can see that we have shipped all the amounts of the bushels from the centers. So 275, which is the same as what is available, 400,000, which is also available, and 300,000. And we could ship to from Mount Dora to Ocala 200,000 because of the distance. Mount Dora to Ocala is the shortest distance, and then since we are left with 75,000, that 75,000 will go to Leesburg, where we have 40 miles and not 50 miles to Orlando. Orlando will be a little bit far. So from Eustis, we can see that we are not shipping to Ocala because Ocala has received 200,000, and that's the capacity which we have. We received the exact capacity. So Eustis will ship 250 to Orlando and 150 to Leesburg. You can see, although Eustis to Leesburg is the shortest distance, but we had shipped 75,000 from Mount Dora, and so the left, which is 150, should come from Eustis, and what remains will go to the next shortest distance, which is 30, not 35, and so that's it. And now Claremont is very close to Orlando, and so we will ship everything that we have, which is 300,000. Still, we'll be able to supply 5,000 550,000, which is 50,000 less to 600. But that's okay because we can ship equal or less than the capacity, not more than the capacity. But what is important here is the total distance. So the company will minimize the total distance if they can go with what we have, or with what Excel or Solver has suggested. And this is the minimum possible total distance the company can incur to supply all these products. And so it will be able to plan accordingly if now they have this answer that these are the miles which they should cover, and that is the minimum total distance. So since this is okay, then I can click OK, and I can provide sensitivity analysis, or I can provide the summary of the outcome. That's all.